Now we turn to population proportion. So we have two different populations and independent. In each population, we're going to be counting the proportion of success. And here you define success in whichever way you want, depending upon the situation. So we have P sub 1 proportion of success in population 1, P sub 2 is for population 2. And we have sample size, take a sample from that population. We don't know the value of P sub 1 and P sub 2, so we estimate those values using P bar sub 1 and P bar sub 2. And then here is the confidence interval formula. Okay, where this part is the standard error, and then when you multiply by z, you get the margin of error. Okay? And in case of hypothesis testing, then we have a slightly different formula. First, let's look at an example of confidence interval, and for this, let's look at the example from your textbook. So we have two different offices that prepare taxes, and we want to look at the proportion of erroneous tax returns from Office 1 and Office 2, and is there a difference between those two? Population proportion of erroneous tax returns. And for that, we take random sample, and Office 1, we took 250 tax returns at random, 35 of them were erroneous, and from Office 2, we took 300 returns, and of those 27 were erroneous. So we can compute 35 over 250 is the sample proportion of erroneous returns from Office 1, and similar statistic erroneous returns from Office 2. Okay, let's now put all of this together, define the populations, and compute the sample proportions. So population 1 is the tax returns submitted by Office 1. Population 2 will be tax returns prepared by Office 2. Then P sub 1 will be proportion of erroneous tax returns for Office 1, and P sub 2 will be for Office 2. And what we require now is 95% confidence interval for the difference between those two population proportions. Okay, so now we have defined the populations, the proportions, and what we want. Now from the text, we know these are given. Okay? If these are not given, if you have the raw sample, then you have to calculate these numbers. So sample size, you'll use count, so 250 and 300. Number of returns with errors is 35 and 27. Confidence level is 95%. Now P bar sub 1 and P bar sub 2, the point estimates are how many were bad, and bad is the success. You remember, success in quotation marks. That's what we are trying to analyze. So that divided by the sample size. We can express this as a percentage if you like. Now point estimate for the difference is that minus the second one. So that's our point estimate for the difference. The standard error of estimate, okay, so that's that part. Okay, so it'll be square root of, okay, so now P sub 1, you have to use brackets in a, properly. P sub 1, right, times 1 minus P sub 1 divided by n sub 1. So that's the first part. Okay. And then add to that, and since multiplication and division has a higher precedence, this is okay. So, and then this will be computed, then only the addition will take place. Then that one, P sub 2 times 1 minus P sub 2 divided by n sub 2. Now close parenthesis and make sure that you have the proper number of parentheses, and that's our standard error. Now we want confidence interval, so we have to find z value. So 1 minus confidence level is alpha over 2. You don't really need to do this step by step. But remember, we need two tails, so we need the right hand side value. So you have to, for norm.s.inv, you have to give the cumulative probability, and this is cumulative probability is 1 minus alpha over 2. So 1 minus alpha over 2. Okay, we could do all that inside the norm.s.inv, 1 minus alpha over 2. So that will give us the z table value. Z sub alpha over 2 is nothing but, this is nothing but z table value. Then you take the z value and multiply that with the standard error of estimate. That gives us the margin of error, and then take the point estimate of the difference, which is right here, minus the margin of error, and then the same point estimate for the difference plus margin of error will give you the upper and lower limits, and then you do the interpretation. Here we want required is 90% confidence interval. I used 95%, it should be 90%. Let's go back to the text and see what we want. We want 90% confidence interval. So I did this wrong. Should be 90%. So this should be 90%. Okay. In which case these are the lower and the upper limits. And the interpretation is, so we are 90% confident that the difference in the proportion of erroneous returns between the two offices is between 0.48 and 9.52%.